Hello! In this video, we're going to look at how to construct perpendicular lines. Now, already we've dealt with one very popular type of perpendicular line. We've looked at a perpendicular bisector. Now, remember, perpendicular means a line is intersecting another line to make right angles, and a bisector means a line segment's being cut in half. So, when we go to construct a perpendicular bisector, we start at either endpoint of the segment, stretch out more than halfway, and make an arc. That arc should have two intersections once we have one from each side. So we went from M. Notice when we went to N, we didn't change the length between our compass at all. We wanted to make sure that was intact. But you should have two intersections above and below, so that way we can take our straight edge, line it up so that both points have that intersection. Notice that this line has cut our segment in half and also has 4 right angles. So remember, this construction is useful for us because it finds how to bisect the segment. We can locate the midpoint. We create that set of perpendicular lines, which we said forms congruent right angles. But there's also an additional way that we can construct perpendicular lines. Not all of them have to include the bisector. So we want to be able to construct a perpendicular line that passes through a point that's on the same line. So we're going to look at something like that. Now notice that where this point A is, it's not the midpoint of the segment. So we can't do a perpendicular bisector and just hope that it's going to pass through A. Instead, what we need to do is figure out exactly how far apart they are. And what I mean by that is we have this A. We want to create a circle around A. And it could be at any length, but I'm just going to make it so that it intersects twice. And you don't even really need to have a full circle. What we need is an intersection on both sides that are equal distances away. The reason why we want an equal distance here is because now we know a construction that could be useful here. So our first point was to draw a circle, and we're going to label the two intersections that we just created as B and C. Now we know they're equal distances. So for part B, when we talk about why they're equal distances here, think about what we've just done. AC and AB are the same distance because A is the center of a circle. These two line segments are the radii. So for part B, I want you to fill in that AB is congruent to AC because all radii of a circle are congruent. Now that we know that there's equal distances on every side and that A is the midpoint, we know a segment can be cut through that midpoint from the construction we've already done. We can construct a perpendicular bisector of BC now, as we did on the top of this sheet. So when we go to do that, our same construction as earlier, start at either point, B or C. We want to make sure we stretch out more than halfway, so we want to be past A. We know that's the midpoint. We can go way further. We can stay just a little bit further. It doesn't matter that intersection that we have, but we are going to make that arc above and below the line segment. We're going to keep that same piece intact. Now notice I'm going to point B for this intersection. And now, because I have the intersection above and below, this point is going to pass through here. And I'm just going to slide that over. You probably won't run into that issue when we're using our straight edge. It's just my computer tools. But once I slide my line back over, notice it passed through the intersection above and below and passes through A as well. Okay. So we have a line that's perpendicular, not necessarily the midpoint of the whole line though. we did use the midpoint, but we used it just so we could find that equal distance to use the perpendicular bisector that we're already so familiar with. So that's how we would construct a perpendicular line to a point that's on that same line. Because remember, perpendiculars should intersect. One other scenario is when we're given a line, segment N, and the point is off the line, and we want to construct something that's perpendicular that passes through A. So in a similar fashion, we still need our arcs. So we're going to start with our clear piece at A. So it's different from our parallel construction that we've seen in our previous video, but we start with the clear piece at A. Now, our goal is that we need to make an arc that intersects this line twice. If you ever make a line that, or rather an arc that's too big for our line, you can always extend the line. Remember, lines go on forever. So that's our first piece. And we're going to label the intersections B and C again, just so we have a reference point. And again, you don't need to point in the exact letters every time. I just wanted for this video for us to have a reference. But we found points B and C. Explain why A must lie on the perpendicular bisector of B and C. We'll imagine the same idea as what we dealt with before. A to B, even though it's not drawn in, and A to C here, they're going to be equal distances again. AB and AC are radii again, because remember, if this is the center of our arc, we can make a full circle around. Because we can make a full circle, there's infinitely many radii. And if it comes from this center point, those are our two intersections. So for part B, I want you to take a second to write in AB would be congruent to AC, because all radii are congruent. And now just that same way, we can make a perpendicular bisector. So remember, that bisector is popular to us. The nice thing here, we can go any length, we could change it. We want arcs from B and from C. And when we draw in that line between the 2 points, notice that our point A will also be on those intersections. So again, bear with me as I straighten out where my line passes through. But we have the 2 intersections, and it passes through A, making a perpendicular line here. Now, because we have a point that's off the line, remember, we always need 2 points to have a perpendicular line, or any line for that matter. So if you only showed the arc down here and connected A to this intersection, that would count. So just to see what that would look like, I have my initial arc, and you have an intersection below. So as long as there's that intersection below down here, and you have a line that passes from A through our intersection, then we're okay. So that would definitely count as full credit. If you want to just stick to using the 2 intersections above and below, that's fine too, because it's what we've been more used to throughout this. Now, as we look at the back page, there's something called a circumscribed circle. Now, it's where a circle which passes through all 3 vertices of a triangle. When we look for that, with all three vertices being on the triangle and the circle, that means we're looking at something like choice 2. Okay, notice each of the three vertices of the triangle lie on the circle. Now, there is a way to make this construction happen for us. To make sure that all 3 points lie on our circle, we can construct the circle around this triangle ABC. The first thing we need to do is find the center point of that circle where all 3 points are going to be equidistant. So if we look back to what our image is going to look like, notice this center of the circle, we still have, it's going to be a radii to each of the 3 points. So we're going to need to first figure out where the center point has to be of this circle. So we're going to construct the perpendicular bisectors of 2 of our sides. So the 2 sides we're going to use are AB and BC. And you can make the judgment of which ones you want to use in the future. You don't have to use the 2, AB and BC. You pick whichever ones you want to bisect. But notice the way to first start this is constructing perpendicular bisectors. So from A to B, I'm going to make sure to go more than halfway. We make our arc from both endpoints. So we have the first perpendicular bisector. We're going to repeat the process from B to C. Now notice where those 2 perpendicular bisectors intersected, this point right here, that's our equidistant point. It's got to be equidistant, so that way that's going to be our center point of our circle. So explain why point D must be equidistant from all 3 vertices of the triangle. Well, we've just bisected 2 of the 3 sides. If I bisected the last one, it would pass through that point as well. So we don't really need to have that point shown just yet. But since all the vertices of the triangle are going to be equidistant from that center point, we know that we can start here and we can stretch to any one of our vertices. And since it's equidistant, notice what's going to happen. A, B, and C, we make our way around so that that circle becomes the one that has circumscribed our triangle. So we have a circumscribed circle. That means circumscribed has all 3 of those points on the edge of our circle here. Because it's a circumscribed circle, that point that we just found as the center is known as the circumcenter, because it's the center of a circumscribed circle. And if we ever wanted to find that center point, we would just use the 2